So the lookup translation, to understand the lookup translation, so just see this party table first. Alright, I was inserting 2 records here, so you can just neglect these 2 records. Alright, now so just check my address table. First let's check the address table base object and check the okay, this is my staging table of address staging table, and if I go and check it, then I can see the party ID. What is the party ID? CKR8011. So it's the source key. Alright, now if I go and check the party ID in the address table, that's the party ID in the address table, it is 1234. It's not the source key anymore. It's 1234. It's a foreign key that's pointing to the row ID object of party table. So the translation of CKR8011 to 1, that's what is the lookup translation, and that happens via this query. This is the query that is internally. Informatica will fire this query internally to do that thing. So if you open this, okay, so this is the query Informatica will fire. That is, what will happen is this staging table will join with this cross-reference table, party cross-reference, staging of address with party cross-reference. Okay, this is address, this is party, and based on this particular key, party ID is equal to row ID, the PKSRC object, and the source system name, and then it will fetch the row ID object, and that row ID object is nothing but that is stored in the base object party ID. So this is stored as the base object party ID. So basically your input will be what will be your input? Input will be party ID is equal to, that is a dot party ID is equal to, let's say we have something like CKR8011, right? Okay, CKR8011, and the output is 1, right? So, and 80111112, I think, and this is 2. Okay, or you can say like in and I will say like this. So this is getting translated. See, this is called as lookup translation. This is getting translated to this. That's what is the lookup translation. Using the query, of course, what you're seeing here, this is getting translated to this value. So your input that you're sending to the lookup is, this is your input, and your output is this. Okay, that's what is the concept of lookup translation. You try to understand this query, then you know what we're talking about. Okay, now let's start with the tokenization. So the concept of tokenization, will start that today. Okay, tokenization means it's the end of one story and this it's start of another. That's the load process is done. Now we are moving ahead into the surging ahead to tokenization. So tokenization. What is tokenization? Tokenization is a part of match and match process especially. Okay, but before, let's forget about this word tokenization. That's technical. Let's try to understand why do we need something called as tokenization. Okay, and to understand that, first of all, let's try to understand slightly about the matching. Not much. Okay, so on matching side, let's say that I'm a layman. I have No idea, not intelligent. I have no idea at all how to do matching. And I got a task that I need to perform matching. Okay. So the first step that I need to understand. So how will I do matching? Let's say I have these records. I have 101 John and the address is HNO 101 101 Texas, Texas. And I have the second guy, third guy. This is 102 K, John K, KS. All right. This is A. This is B. Okay. So I have three guys, John K, and John K Smith. That is John KS. Okay. And the addresses are similar, not same. Or let's, for the sake of simplicity, let's make it same. And of course, other details are there. So which I have not considering here, written here. So other details means the phone number, gender, date of birth, dot dot dot, all the personal details. I have it. Just assume that it's there. Okay. Now I got a task that I need to do the matching. So why would I do something like that? Because I want to understand if these three records are same, referring to the same customer, or are they different customers. With that objective in mind, I would like to perform the matching, right? So do just as a layman, when I want to do matching, what will I do? I will try to match this record with this record and this record with this record, and I'll try to match this record with this record. Third one is not necessary because it's already done, but that's okay. Let's say plain mathematics. So that's what I'll try to do. So this is very simple. Anyone can understand what I'm doing here. So first thing to observe here is it possible to match this record by itself? Not possible. Like it's the same question as, can you clap using just one hand? No, you can't clap using one hand. You have to use two hands. So similarly, matching also you can only do when you have two records. You can't match on a single record. You have a shoe. When I say shoe, it's always a pair of shoe. What will you do with a single shoe? It's useless, right? So what we are talking about pairs, because we want to match the pairs. We can't match single records. So the first important concept in matching is the pair. So match pair, that is called as match pair, because first you create the match pair, then you do the matching, right? So you decide that if you're going to use your both hands to the clap, or something else, your head and your hand for the clap, or something. So first you decide, then you clap, right? First you use your hands, then clap. So first step to do the matching is create the match pair. Second step is execute the match pair. Create the match pair and execute the match pair. You understood why creation of match pair is necessary. Again I'm telling, and both are different steps. So you have gathered your hands does not mean that you're going to clap, or you can clap slowly, you can clap in a bigger way, or you can do many things. But the first step is creation of the pair, and then you execute the pair. This is just like a cricket match also. In a cricket match, what do you have? So in a cricket match, let's say you have India, you have South Africa, you have UK and other teams. So if you want to if you want to see a match, entertainment, you want to see something going on in a stadium, then what will you need? Can you select all these three and like throw them into a stadium and say that, okay, you guys play, we'll watch? It's not possible. Three teams cannot play against each other. So to play, first step is nothing but create the match pair. So create a pair like, okay, India going to play against South Africa. That's called as a match pair. Second thing is you execute the match pair. That's the second step. You execute the match pair. Okay. Now, in the first step, I just created a match pair. Alright. Now, can anyone tell me India will be the winner or South Africa will be the winner? Do you know who is the winner? No. You don't know. Why? Because the match has not started yet. The match will start in the second step. In the second step, they will play, and then I will know if uh, India is winner, South Africa is winner, is it a draw or whatever it is, right? So the basic step of matching is creation of the pair and execution of the pair. Today we'll be basically focusing on only the creation of the match pair. Only on the creation of the match pair. So creation of the match pair is just pre-matching. You understand? This is not actual matching. You understand this clearly that this is not matching. This is pre-matching, prerequisite to the matching. Once you have prerequisite, prepare for the matching, then you can perform the actual matching. Okay, now let's go with the, let's try to understand. I'll put it here. Okay, let's try to understand something. Let's again talk about a layman. So layman, I would like to match this with this, this with this, this with this. Three types of matches, right? So if I have to note down how many matches I'm doing, so how many matches I'm doing, see what are all these records. These records, where are these records? Where are these records? These records are there in my base object. I have done the load and these records are in my base object, and the consolidation indicator is what? 4. Of course 4, right? So how many match pairs? Question is how many match pairs? How many match pairs are formed? 3. And if I have to put that in mathematics, it is actually 3 combination 2, that is equal to 3. So three things, records I'm combining for 2 combinations, and that is called as 3 combination 2. You would have seen that in your 10th class mathematics. Okay, now let's make it complicated slightly. Let's say that now this was the case when I had just 3 records in my base object, just 3. Now let's say that I have 3 new records plus I have 10 million records in my base object. How much? I already have 10 million records in my base object, and for those records the match and merge is done. For those 10 million records the match and merge is done. So all these 10 million records have consolidation indicator as 1, and these guys have consolidation indicator as 4. Now let's try to understand how the matching will happen. So how many match pairs in this case? So this one first is among records with consolidation indicator 4, that is 4 cross 4. So consolidation indicator 4 with consolidation indicator 4, and that is equal to 3. The same old thing. Now a new thing will happen, that is 4 will try to match with 1. Record number 4, that is consolidation, all the records. See, when I say 4, it means all the record with consolidation indicator 4. When I say 1, all the records with consolidation indicator 1. They'll try to match with each other, and the result, let's see how many match pairs. Let's count. Okay, so how many match pairs? Let me quickly draw this. Okay, so what will happen is the first record will try to create a match pair with the first record here, then first with the second, First with the third, then dot 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 dot. How many? 10 million. Then the second record, again 10 million. Third record, again 10 million. Now that is approximately is equal to how much is it? It is 3 into 10 million. This is 3C2. 3C2, and this is 3 into 10 million match pairs. Now what about this? 1 with 1. How much is this number? 1 with 1? 0. Because Informatica is not that stupid, so Informatica will not do this. Because 1 means master data, 1 means master data. So why would Informatica match master records with master records? It's a waste of time. So this will never happen. Just for understanding, I put it here. 1 with 1 never happens. It will happen if you do it manually. If you go and change the records from 1 to 4 and do it, that will happen. Otherwise not. Okay. And what's the total number of match pair? Total is equal to 3 plus, that is 3C2 plus 30 million, and that is approximately, let's say 30 million. 30 million. Alright, now to match 3 records, I need how many match pairs? 30 million match pairs. Just to match 3 records. It means something is wrong here. Because practically, I will have 10,000 records as a normal volume. So 10,000 is quite a normal volume in MDM. Now there, what will happen? How much will be this number? 10k means 10,000 C2. Okay, and this is 10k into 10 million. Now that is approximately 10k into 10 million, and that is approximately is equal to infinite. I have never written infinite in my keyboard, so don't know where the symbol is. Infinite. So to match 10,000 records, I need infinite match pairs, and infinite match pairs means my job might run for 10 days continuously. So for 10 continuous days, my job might be running. It means something is wrong. So it is absolutely clear that there is something is wrong. So we can't proceed with this logic because I have infinite match pairs and I can't allow my machine to run for 10 days continuously, or I don't even have a supercomputer. What will I do? Okay, now so to correct that, again I'm telling you 4 with 4, that is the match pair, and it is 10k C2, and 4 with 1, that is 10k. This is m cross n, Cartesian m cross n. This is combination. Okay, and so it means something is wrong here. So this is anyway, this is called as a Cartesian method. So what is the problem with Cartesian method? The good thing is it's very simple because I don't have to be intelligent to use this. I can blindly do it. But if I want to be intelligent, or let's say if I am intelligent, I will modify this method. What I will do is I'll use the same Cartesian method plus something extra, some extra logic I'll put it. That is, I'll put a condition over that. Same old logic, but a condition that create match pairs, okay, only if the records have same addresses. So now I'm putting a condition that create match pairs only if the records have same addresses. So here what was happening? Here India versus Kenya. Is it possible? So here it was happening India versus Kenya, which is meaningless because India is definitely going to win. So this is a wrong match pair. So here what was happening is you have a record called as Amit. Let's say John. John is a male, and it was creating a match pair with Linda. Linda is a female. Does it make any sense? At least not to me. So it was creating unnecessary number of match pairs. Now I want to cut it down. So I want to make the relevant match pairs. So I'm using this particular logic to cut it down. And the logic is simple logic. Same thing, same old story plus this extra condition. And the condition is match pair will only be formed if the addresses are same for two customers. Now let's track it down. How many match pairs? 4 cross 4. 4 consultation indicator 4 with 4. How many match pairs? So all these three guys have same addresses. So how many match pairs? There's no impact. It is 3C2, or you can just say 3. Now talking about 4 cross 1, how much can I expect here? Let's picturize that. So I have 10 million records here in this box pyramid. Okay, now the first record, try to understand that. What do you think, how many people will be there in, let's say, US? We are talking about US. How many people will be there in US with the same address? What do you think, how many people will be there? At most 1, 2, 3, 4, 5. Do you think more than 5 people will be there at a address? Not possible. Or let's say 10 or 20. Do you think ever it will be more than 15, 20? No, never. So it will be somewhere around 3 to 20. Probability, I'm saying 3 is the least, 20 maybe the most, or very rarely for 1, 2 guys it might be 100. Very rarely. But let's say that I have 5 guys or 5 people who are using the same address. So 1, 2, 3, 4, 5. So how many match pairs? 5. 5 match pairs for the first guy. Second guy, John K. How many match pairs? 5. Third guy, 5. How much is that in mathematics? That is 15. So approximately 15, or you can say 15 to 50, somewhere around 15 to 50 match pairs between that. Okay, so between 15 to 50 number of match pairs, and total it will be how much? Let's say somewhere around on the safer side 20 or 30 or 40 or something less than 50, or let's say 20. Okay, now 20. So what is this figure here? Earlier this was 30 million, and from 30 million I have dropped to 20 number. 20 is a very small number compared to 30 million. It's a very small number, 20. And 20 is perfectly okay. That's what we are looking for, 20. So this logic is quite good. Why? Because it's bringing down this huge beast to a small number and helping us. Okay. Now see a one. Okay. Right. 1 minute. Okay. This 20 number is now, but still I have a problem. The problem is if there is a slight variation in the address, now what? I have this variation in the address. So what will happen now? If I have variation in the address, then let me count. So what is this value and what is this value? This is 0. This is 0 to 10 something. Let's say there are some guys with the same address, or you can just say like 0, let's say. So total count is 0. So this works fine, but the problem is if the address there is a slight variation, this won't work. Otherwise it's okay. So I need to fix that. To fix that, I'll slightly tweak this logic. What I will say is, so create match pairs only the records if the records have identical addresses. So if the records have identical addresses, then you create the match pairs. That's the objective. Identical. So do you think this is identical to this? All these three addresses are identical. So now what will happen is, if I count 4 cross 4 and 4 cross 1. So 4 cross 4, this will be approximately 3 results, and this will be approximately like 20. So approximately this will be like 20 to 30. Total number of match pairs will be 20 to 30. Okay. So the third method that you're seeing here, that is the method that will be used practically. You will not see other methods normally. Like these two methods, the first one is never used. Absolutely no doubt about that, because I don't have a supercomputer. Second one is sometimes used. It will be used only rarely sometimes. And the third one, that is the one that is most widely used, and that's a, you can say, in any project they will use this default one. Records, if they have identical addresses, then that's the logic. Right? So the third is a fine thing, but still I have a problem. The problem is, I have a problem with this word identical. This word identical. What is the problem? On what basis can I say that, uh, on what basis I can say that something is identical to something? Like for example, if I call someone and if I take a vote that, do you think this is identical to this? Someone will say that, yeah, I think so. This is identical because they look same and there's slight variation. If I take some other opinion, then he or she will say that, no, this is different. Definitely different, because this guy is living in the ground floor and this guy is living on the first floor, and they have nothing to do with each other. They're different. So the word identical is slightly identical, or you say similar, or you say fuzzy. We use the term fuzzy. Technically we use the term fuzzy, identical, similar, fuzzy, those kind of things. And this is called as exact. We have two popular words here, exact, and we have a word called as fuzzy. Right? So that's the challenge here. How will, see, when I'm asking you, I have 100 opinions. Like someone is saying it's identical. Someone will say that I don't think so. Now we are talking about a computer system. I'm not here to take your opinion. I am here to take Informatica MDM's opinion. Because this will be, Informatica MDM will be executing this. So how will Informatica understand if this is identical to this or not? On what logic, on what basis? Because computer is a stupid box. So how would a stupid box or an idiot box understands, will resolve this issue, right? That's what we are talking about tokenization now. It does it using a process called as tokenization. Okay, so first of all, before going through tokenization, let's try to understand what exactly is a token. What is a token? A token a token is a 8 char alpha numeric value. So token is an 8 character alphanumeric value. So how that will look like? Something like this. You have alphabets, numericals, you have special characters or characters, symbols, combination of all. This is technically called as a token. A token is will always be 8 char, will not be more, will not be less, always 8 char alphanumeric value. That's what a token is. Okay, and um, tokenization is a process where Informatica will generate tokens. What's tokenization? Tokenization is a process where Informatica generates token for all the new records. So for all the new records, you will see Informatica will generate tokens. It means that this guy, will it generate tokens? Yes. For this guy, yes. For this one, yes. What about the 10 million records? No, not for them. Because for them it was already done long time back. So each one only one. So for the new records, they will go through the tokenization process. And what will happen is Informatica will generate around 7 tokens. So it looks something like this. There will be some variation in the token, but not much. I mean, like the initial 5 characters normally will be the same. There will be variation in some of the characters and dot dot dot. 7 tokens for each record. 7 token for and then for this guy also 7 tokens. Okay, so I have 7 tokens generated. Informatica generates 7 tokens for each record. Now you might have a question like, okay, that's okay, 7 tokens, but on what basis? On what basis? The basis is, 1 minute. The basis is address. On the basis of address, it will generate the 7 tokens. That is what it will do. You would have seen a coffee machine. So in coffee machine, you put the water and output is coffee. So it's like the same thing. So you give the address, you supply the address, Informatica will take this address and Informatica will give you 7 tokens. How? What basis? Now that's the logic of the coffee machine. So that's what is Informatica's internal logic. You don't need to worry about that. And you can't worry about that also because that is completely internal to Informatica. Okay. So how it is generating and all that, you can't, you have no way of knowing that. But yes, in a coffee machine, you would have seen there will be special button for strong coffee or small coffee, or let's say there is a button for coffee, tea and all that. So if you want your coffee to be strong or less strong, all that, an intelligent coffee machine will allow you to choose it. So here also, you can influence the tokens. So if Informatica is creating 7 tokens by default, you can tweak something to generate less tokens or more tokens. So if Informatica is generating 7 now, you want Informatica to generate 10 tokens. Is it possible? Yeah. I mean, you can increase the number of tokens, you can decrease it. Okay. And all these tokens will be stored in a table called as strp table. So this is like something like this. I'll directly show you from this ORS sample so that you can correlate that. So ORS sample, if I go, this is stored in strp table. Okay, this is strp table and this is how the tokens look like. So okay, the tokens, this is how the tokens look like. For every record you will see, for this guy you see how many tokens, 4 tokens. For this guy, I see more tokens. Now that's strange because for this guy, I see 4 tokens. For this guy, I see more tokens. Is it possible? Yeah, it's possible. Because see, a person who is weighing 150 kilos and a person who is weighing like 50 kilos, do you think they will eat the same food? Of course not. So the requirement for this guy is definitely more. So it means that if your address is like this, very long address, and other address is like this, do you think the tokens will be same? No. For this, Informatica might generate 30 tokens. For this, Informatica might generate only 5 tokens. But so why did I say that 7 tokens by default? Now that is just for your understanding that for a normal guy, if you ask me how much he will eat, I can tell you like 2700 calories or whatever the scientific thing. That's for the normal guy. So for the normal guy, it will be 7 tokens. So normal address means something like this, like some length like this. It will be 7 tokens. But this number is never fixed. Just for your understanding, I'm telling 7 because normally for most of the customers it will be 7, but it's not fixed. Everyone has its own style. Okay, but let's say currently Informatica is generating 30 tokens. Can I increase that? Yes, there are options to influence the decision. So if Informatica is generating 30, you can force Informatica to generate more. So it might generate 35 tokens. Possible? Yes. Okay, but anyway, first let's check it why we are generating tokens. So 7 tokens, 7 tokens, 7 tokens. Okay, now the logic is like this. If there is a single token among, if a single token is common among 2 records, then a match pair will be formed. At least 1 token. More than 1 token, I don't care. If I have more tokens common, that's okay. That's not a problem. But at least 1 token should be common between these 2 records. So from 7 to 7, 7 with 7, if at least 1 token is common among these 2, then a match pair is found. And you can see here clearly that this token, the first token, is matching the second token. Okay, the first is matching with the second token. You can see they are exactly same. So what will happen now? A match pair will be formed between 101 and 102. That is 101 and 102 match pair is formed. Clear on the process of tokenization? You have any doubts till this? If you have any doubts, you can ask. Otherwise, I'll proceed. Okay, no doubts, that's okay. So my tokenization is based on address. You might have a question like, do I always have to do it on address, or can I choose something else, some other column? Yes, you can also choose a different column. You can do that. Okay, you can choose a different column like name or the organization name. You can either use this name or the organization name or the address. Okay, and that is typically configured here. So if I go here and check this, let's say let's not do the configuration in our ORS because I will show that later. I'll do it here. I'll just show you here. If you go here and take a lock, then see here, you can see person name, organization name, address part 1. So you can provide either the person name, organization name, address part 1. Now you might have a question, only 3? Yeah, only 3. That's correct. That's a limitation. Only 3. Only address or person name or organization name. You can't generate tokens on anything else. Okay. Now, and you can see if I choose, let's say, address part 1, you see something called as standard, extended, limited, preferred. Now these are the different gears in your car. Like default is standard, so it's 7 tokens. Extended means more tokens, probably 10, 8, 9, 10 tokens. Limited means 3 tokens, normally 3 to 4 tokens. Preferred means only 1 token, only 1 token. So this preferred option is same as, if you choose preferred, that is same as like this exact matching. If you choose any of the other things, that is the second option. Okay, so can you tell me how technically, if I have to implement Cartesian method, how can I do that using this? I can make a dummy column, as I can base my fuzzy match key on a dummy column. Dummy column, let's say I create a column called as dummy, and the value is 1 for all the guys, it's 1. And if I do that, then that's nothing but your Cartesian method. But normally we don't use this. Okay, that's what is called as the tokenization. Why do we need tokenization? We need tokenization because we have to create match pairs. If we don't have tokenization method, then this is what will happen. Disaster. We have tokenization method, that's why we have very less match pairs. If we don't have tokenization, we'll have millions of match pairs. So tokenization is a method where you create the match pairs based on the tokens. If the token is same, at least one token, or any token if it's same, match pair is formed. So I have 2 match pairs here, actually 3, but Informatica will internally cut down the third one. It will cut down the third one because it's not necessary. So I have 2 relevant match pairs. Now can you tell me if 101 and 102 are same or they are different? I can't answer this question. Why? Because I have not executed the match pair. Once I execute the match pairs, then I can tell you, okay, they are same or they are different. Not now. Right? Now let's understand on the execution side, execution of the match pair. Okay, so open this. Right. First of all, try to remember the term that create match pairs if the records have identical addresses. So here the address will be called as fuzzy match key. You understand? The address is nothing but my fuzzy match key. So what is a fuzzy match key? Fuzzy match key is the key based on which tokenization is done. Let's say if my tokenization is done on person name, then person name is my fuzzy match key. Clear? Right. Now moving ahead. Now once the tokenization is done, what is the result that I have of the tokenization? I have the match pairs. So I know what to match with what. So 101 and 102. I have this match pair. Now I want to perform the actual matching. And I want to know the result that it's a match or no match. Okay. Now if I want that, then what I need to do? I need to perform the matching. So matching means what? Matching means I will take some details of this guy and some details of this guy, like the name, address, telephone number, bank account number, gender, those kind of things of this guy, and then I will take those details of this guy. I'll compare that. Okay, name is identical, date of birth is same, gender is same, bank account number is same, or some other details. So I feel that they are same customers. That's called as a match rule. A match rule is a rule based on, or a match rule is nothing but it's a group of columns. So for example here, let's say name, if name is identical, date of birth is same, and gender is same for two customers, then I will declare that these two customers are the same. These two customers are same. That is called as a match rule, and that's what is specified here. If you go here, if the name of two records are identical and date of birth and gender is exactly same, then that's a match. That's called as a match rule. Right? What is a match rule? Match rule is a combination of match columns. Combination of match columns. So I have this match rule, this, four match rules. Now why do I need multiple match rules? What's the point of going with multiple match rules? Do I need the multiple match rules first of all? Let's try to understand if I need the multiple match rules or not. See, let me take a very simple scenario, then you can justify yourself, you can justify if you need, why you need multiple match rules. Let's say that I have a system MCKR, MLO, MCCS. Now let's say in CKR I have, let's say SSN number is mandatory, and in my MLO also same thing, and my MCCS also same thing. SSN number is mandatory in all the three cases. So how many rules do I need? How many match rules do I need? Just one. That is, if SSN number is same, customer is dupe or the same. Simple. Only one rule I need, not more than one. But let's say that in the third system, SSN number is not mandatory. Right? Let's say the driver's license is mandatory. In the third system, driver's license is mandatory, and here SSN number and driver's license is mandatory. So if I just go with only one rule, what will happen? If I go with one rule, what will happen? It will identify these two records as duplicate, but what about these two? No, it cannot identify because SSN number is different. This guy does not have an SSN number, so it will be null. So that's where I will need a second rule. I will need two rules. If driver's license is same, the customer is same, or it's a match. It's a match. So you can understand that in this very simple scenario, I need how many match rules? Two match rules. Two match rules. Let's say that I don't have a unique identifier. So unique identifier, not there. Then life is very difficult. Because if I don't have a unique identifier, I need to play around other things, right? So I need to say that name, if name is same, like identical, date of birth, gender, bank account number is same, like it's matching, then declare that as a match. Now if that's not working, I'll try a different method. Let's say the first one is this. If this is not working, then I'll say name, then the bank account number, and or some other identifier. If that's not working, I'll use some other thing. Now you might have a question, why do I use name always in all the match rules? I am using name because I'm taking advantage of that, because I know that if two customers are same, normally their name will be identical, at least some identical, something slightly identical, if not much. So that's the reason why I'm using that in every rule. So then I will create all the rules. So the steps on how to create the rule is how. So if I go here, first rule is name of two records are identical, name and date of birth and gender. That's rule 1. Second rule is date of birth and gender are exactly same and first name is identical. Then I have third one, I have fourth one. If you check the first one, that's like a gunshot rule. It means definitely we are talking about the same customer. I can't say the same thing about second, third, fourth. Let's say the fourth one. Fourth rule says that phone number, gender, postal code. If these are same for two customers, declare the customers as uh, duplicate. Or let's say this one or this one. Any of these rules, all these rules are not gunshot rules. It means that if this rule is met, it is still possible that the customer might be different. It's 50-50, something like that. So possible that the customer is same or possible that the customer is different. Right? So a gunshot rule will always be tagged as auto and a non-gunshot rule will be tagged as manual. Why? Because if something is gunshot, I'm sure. So I would like to merge it automatically. So that's why this is auto merge. But if I'm not sure, I don't want to take a risk. I don't want to merge. I'd like to keep the records as different. And see, let's say these two records resulted in auto merge. You know what will happen? If you run the job, automatically they will be merged. But let's say if these two resulted in manual merge, what will happen? You run 1,000 jobs, but still it will not merge these two records. Someone has to go and manually check and manually do that. That's why it is called as manual merge. Someone has to do it manually. Where to do it manually? Can be done in the merge manager, in IDD, or in using SIF. Many places it's possible. Right? So that's why this is auto, this is manual. Now, who will create these rules? But before that, first let's see the order. So first what will happen? First, let's say this record, this rule will be executed, rule 1. So if rule 1 is not positive, you understand, the result of a rule can be positive, negative. Positive means resulted in a match, negative means no match. So the first rule can be positive or negative. If it's positive, what happens then? If it is positive, you put a full stop. That means you stop the execution and you declare the results as match. You understand? So if the first rule is met, you stop the process there and you declare the result as match. But if the first is not met, then it will go to the second. And if the second is not met, third. Third is not met, fourth. Fourth is also not met, then it will declare the two records as unique. It declares the records as unique. Let's say the third rule is met. What happens now? If the third rule is met, it will not execute the fourth one or this one. It will declare the record as manual merge. Declares the record as manual merge, and it stops the process there. That's the objective of the match rule. You're going to configure all these match rules, okay, and we'll give a full stop to this session by explaining on what basis a business analyst is going to create this match rule. See, the match rules will take approximately 1 to 3 months minimum to create, because it's a rigorous process, right? So on what basis a business analyst will do, let's study. The basis is the business analyst will depend upon data profiling. So first, data profiling. Using data profiling, you will understand all the important columns. So first, let's say you will profile CKR system, then you will profile MLO, then you will profile MCCS. So there you will understand all the important columns in CKR, all important columns in MLO and MCCS. You list down all the important columns first. Then you do a join analysis. What you do is you take a record from CKR and take a record from MLO. Let's say you pick the John's record from CKR and you pick John's record from MLO. John record from CKR, John record from MLO. It might be John here, might be John Smith here. And you compare the two records step by step, bit by bit. When you compare it, you will see that, okay, the name is identical, and yeah, the date of birth is matching, it's same, the gender is same, the bank account number is same. Then you list down all the columns that are matching. So you list down all the columns which are matching, and you do it for 100 to 300 records, and you list down all the matching columns, and you create a order. The order is like, let's say 300 records you have matched. If you feel that a name is normally identical for maximum number of records, let's say 290 records, you saw that the names was identical, so you put it here. Then you saw that the gender is normally same for 200 customers. Then you saw that the date of birth was identical for 150 customers. Then you list down all of them, all that columns you list down, right? And then you finally create so this column is nothing but, it's called as a match column. That is nothing but this. All the columns that are going to participate in the matching. Okay. So list down all the columns, and once you list down all the columns, then you create a match rule. So you create a match rule, something like this, and you test it. You create a rule and you test it, how it's working. Are you able to catch the duplicates or not? You test it rigorously. So moreover, this is like an error and trial. Error and trial. You test it. If it's working fine, then that's okay. If it's not working fine, what do? You change this rule. If it's working, doing under matching or over matching, you add or remove a new column. If it's doing over matching, you add one more exact column in the rule. Otherwise the reverse. And finally you create this columns and then these rules. So it's based on profiling plus a join analysis, where you compare different source systems and to see the results. Right? I think it was more over a theoretical session, so we'll try to stop it today. Yeah, if you have any doubts on today's session, you can ask. Okay, if you have no doubts, that's fine. You go through this session, and if you get something, then you can ask.
Sunil, Naresh here. I have one question here.
Yeah, that is.
If suppose two records got matched, it will generate same token number, is it?
If two records get matched,
Match? Yeah, will it generate the same token number?
no, your question itself is a bit confusing. First, you're saying if two records got matched. See,
I mean,
tokenization,
same, exactly. Yeah.
yeah, first of all, understand tokenization is based on the fuzzy match key. That is the address in our case. Okay, it has nothing to do with, let's say, let's take this scenario. So let's say this scenario, John, and this is Frank, and this is, let's say, Abel. So will it generate tokens? Yes. Will it create match pairs between John and Frank? Yes, it will create match pairs. So match pairs it will create, but when it goes for actual matching, the result will be negative, no match. So these are two different steps: creation of the match pair and execution of the match pairs.
Okay.
Okay. Okay. Thanks, guys.